Welcome. My name is Andrea Campagner, and in this presentation, I will summarize the contents of our paper titled AI Shall Have No Dominion on how to measure technology dominance in AI-supported human decision-making. In our paper, we focus on the context of AI-supported decision-making. In this context, when we want to develop and deploy a decision support system based on artificial intelligence, it is of critical importance to evaluate the impact that this has on the socio-technical decision-making system. However, the standard practice of evaluation adopted in the machine learning literature is based on validating the AI system as a standalone. However, this is not sufficient because typically we're interested in the impact that the our AI system has on the interaction with the user and ultimately on the accuracy and validity of the final decisions that are made by the decision maker. This is obviously important because the AI system can have an impact on the decision maker that is not only positive, but can also be negative. For example, the use of AI can induce some biases like automation bias or algorithmic aversion. While there have been some proposals for metrics and measures to quantify these different forms of negative impact, and you can find some examples in the table in the bottom of this slide, what is missing in the literature is a unified conceptual framework that generally provides a way to understand the impact of an AI system on decision making. In our article, we try to address this gap by providing a conceptual framework grounded on the theory of technology dominance proposed by Arnold and Sutton in 1998. Basically, this is a theoretical framework that aims at understanding the impact of the intelligent decision aids on decision makers' judgments. And we try to provide a mathematical and conceptual frameworks that builds on this theory. The central notion in our conceptual proposal is that of an interaction protocol that defines how the AI system and the decision maker interact when the decision maker has to make a decision on a new case. And in particular, we focus on a process, on an interaction protocol that has 3 steps. First, the user, the decision maker, provides an initial judgment on a case to be considered without the support of the AI. Then he or she receives the support of the AI, and finally he or she formulates a final decision that has to be made. So we have 3 decisions in our process, and it's clear that each of these 3 decisions can be correct or wrong with respect to the ground truth of the decisions, which obviously is not known. But what is important is that by enumerating the different patterns of correctness and wrongness of these 3 decisions, we can identify 8 patterns that we call reliance patterns that can occur in any experimental setting. And what is important is that each of these reliance patterns, as you can see in the table on the top of this slide, is associated with a commonly occurring bias in the decision making, for example, automation bias and algorithmic aversion that I already mentioned in the previous slides. And we use the frequencies, the counts with which these reliance patterns occur in any experimental setting, in any given validation experiment that has been performed, in order to define 3 different metrics. The first is the technology impact, which measures the overall dominance that the AI system exerts on the decision making. And as you can see, this is defined as the odds ratio between the error that is made without support and the error that is made with support. And obviously, depending on the value, it can signify a positive impact of the AI, a negative impact of the AI, or the absence of any impact. And then we propose 2 other metrics that focus on the negative components of dominance, of technology dominance. In particular, we have automation bias, which is the negative dominance. That is, the AI induces more errors in the decision maker. And we have also detrimental algorithmic aversion, which is the opposite of beneficial dominance. in that if we have some degree of detrimental algorithmic aversion, it means that the AI system was not able to reduce the errors made by the human decision maker. So we have this three proposal and the whole conceptual framework of an interaction protocol and reliance patterns that we can apply in any decision-making setting. And to illustrate the application of our proposal, we conducted 4 user studies in the medical setting with different diagnostic modalities like X-rays, endoscopy, and electrocardiograms. And here you can see the results. Obviously, we have no pretense of generalization for these results, but still, we can see that by the application of our approach, we can discover some interesting findings. For example, we see that in 3 out of 4 cases, the AI system had a beneficial impact, and in none of the studies, we identified some degree of automation bias. Similarly, for 3 studies out of 4, we found no algorithmic aversion, while in one of the studies, we found a significant amount of algorithmic aversion. As I said, the studies obviously have no pretense of generalization because they are focused on a single setting and they are only 4. And one of the most important problems would be to see whether these findings generalize to other settings and contexts. And for this to be, obviously, our metrics and measures and our framework has to be applied by other users. And for this purpose, we have developed a web application that you can use freely. Basically, you simply upload your dataset, which is not stored anyway, so it's private in some sense. And it returns the metrics and the visualization that I shown in the slide before. So it can be used to evaluate the impact that an AI has on the decision making in the context of your interest. And for some reason, if you do not want to use the web application, we also made freely available the code on GitHub. And you can see the links in the bottom part of the slide. So this ends my presentation. I hope it was interesting and clear. And if you have any questions, I will be happy to answer them. Thank you for your attention.